Okay. Yes. Now, in theory, it does not work. You can make it difficult to read. You cannot make it impossible to read. In other words, with a lot of scripting languages, such as even Java or JavaScript, Python, languages like that, where you need to send the source code in order for it to execute, people can see your source code. And some people don't like be able to see your source code. It's their intellectual property. Well, you're not going to really save it too much with obfuscation, but you can. But people do that to kind of mess it up so you can't easily see what it looks like. Here's an example. Okay, here is a very simple Java function. It's got a couple of variables, dogs and cows. It's got a one parameter cat. And we just go, if dog is greater than 5, we set the cow to this, other cow to that, and return the value cow. Okay, pretty straightforward. Indented nicely, no comments, but here it is, obfuscated. Instead of my usual animals, and those of you who've had me in Comp 163 know I usually use animals, we replaced them all with variables v1, v2, no information there. And so we get, and then there was an if statement in the previous program. There's a big if there, and there's no if statement here. The inline if, so it's return, and there's an inline if there. I took out the multiplication by 4, did it by a left shift by 2, actually more efficient, but, and yes, so there it is. And some constants were propagated throughout the program. So that's it. It's certainly not as easy to see and understand. That's obfuscation. Some people think it's really cool. It's not. It sort of kind of works to make it difficult, but not impossible. All right. Oh, by the way, the schedule here is I'm going to go over some of the background material we learned real quickly, and then go over the OWASP 10, which is kind of the core of this. Okay, but now everybody should understand HTTP. Here's getting request. The get command is there's get verb. Then there's the name of the file you want to get with the possible path. You get the HTTP version. 1.1 is very common. And then you have to say the host in the next line. That's required because a lot of systems are hosting more than one website on the same computer. And then it's ended by a blank line, which is 2 underlines right after each other. There's lots of, well, not lots. These are all the HTTP methods. Get, as you know, gets it. Post sends data. In theory, get is not supposed to change the values in the server, but sometimes some systems they've done that. Post is to send information, change things. Let me put patch delete. But with get, post, delete, and patch, you can pretty much do a read, a write, an update, and a delete to a database or a system. So HTTP provides functionality to do all that. Probably seen these with Zap. When you send something, you get a response from the server, which starts with HTTP in the version, some sort of status code, hopefully 200. 200 is a happy status code. If you don't get a 200, you may have a problem. Some exclamation of the status code, and then all sorts of options separated by new line characters. And we've seen many of those. That's followed by blank line, and then the contents of the file, if there are any contents you're sending. As I mentioned earlier in the semester, HTTP 3 is coming out. It's currently supported by 18% of the websites, which is quite a number of them. It's pretty much the same. Instead of using TCP as the underlying transport protocol, it uses QUIC, which is a faster version because it allows multiple channels of information to be said simultaneously without one waiting for the other. It's already implemented in several leading browsers. So it will probably start to take over and replace the other versions of HTTP. And Quick will probably start to replace TCP. Notice, by the way, that that's new, came out this year. Cookies. We talked a lot about cookies. And just a quick review, you know how cookies work by now. I should hope the browser sends requests to the server sends back the response and a cookie. Cookie is a bunch of bytes. That can be any format the server program decides. There's usually a session cookie, which is just an encrypted value. And then every time the browser sends further requests to the server, it sends the cookie along with it. And that way, since the cookies are unique for each user, the server knows that this is the same user that received the original cookie. That, of course, can cause all sorts of difficulties if you steal the cookie or if the cookie is sent someplace else, such as cross-site scripting or cross-site request forgery. We talked about encryption. And the important thing about encryption, not so much the encryption itself, but you have to use it properly. What they call cookbook method, or it doesn't work very well. That's where you, for each block of plain text, you encrypt it. You have one block of ciphertext. You do it again and again. That encrypts it, but it has problems. It's much easier to decrypt instead of a stream system. This is what they call a stream encryption, or this is Cipher-Block chaining, a very common one of the stream encryption methods, where you can see we have the text. It's exclusive ORed with an initialization vector. Then they encrypt that. That's the, then the output of that is used to encrypt the next block. So the encryption of any block is dependent on all the previous blocks. Also, because the initialization vector is new every time you encrypt it, you can take the same file, encrypt it multiple times, and the output, the ciphertext, is different. Makes it difficult. And okay, and now I have a question. I've got several questions for today. Except this is not the question I want. Okay, so let's try this question. Hopefully you can see the polling question. So make a guess. Well, everybody has answered. So we have a variety of opinions here. You can see the protecting information from being viewed is very popular, and all of the above was very popular. The correct answer is B, avoiding protocol problems when sending binary data. Yes, Base64 encoding certainly doesn't compress the data. And that's the most wrong answer. Sorry. Don't worry, these are anonymous polls. You can keep making wrong answers as all you like. But the compressing actually makes the data bigger. The whole purpose of Base64 encoding is to hide special characters. In other words, or allow you to send any binary value as regular characters. In other words, it takes 8-bit bytes, 3 8-bit bytes, which makes 24 bits, and then divides those up into 4 6-bit values. And as you should remember, 2 to the 6 is 64, into 64 different characters. And they use 26 lowercase letters, 26 uppercase letters, 10 numerical digits, and then that goes up to 62. And then they add the plus sign and the slash divide sign, and that gets you 64 different values. So that way, the only thing you see are letters and numbers, maybe a plus or a slash, which, by the way, the slash I know is all 1 bit, so it doesn't occur very often. Yes, so that's Base64 encoding. It's also, of course, really useful for figuring out what exam you should take. Okay, any questions about Base64 encoding? All right. Transport layer security. Oh, hang on. That's me, and I'm sorry. Please stand by. Oh, stop that. I'm sorry. I seem to have some of these slides, a whole bunch of these slides were taken from previous lectures, and some of them have, let's see, some of them have voice on them. So I didn't. Okay, there, I have cleared everything. Everything is gone. And there, all right. Oh. All right, well, you'd think I would learn to use Zoom after all this time. Sad to say, maybe not. Okay, let's try again. There we go. All right. Okay, transport layer security. It's the security in HTTPS. It's a means of providing encryption across the link. It's pretty good because it uses a new key every time. It uses a combination of private key or secret key encryption and public key encryption, or synchronous or symmetric and asymmetric. It uses public key encryption or asymmetric encryption initially, and then it passes a key to the other side. And once both sides have the same key, they use much faster secret key or symmetric encryption. It's used all over for a lot of things. So it's TLS. You might hear a lot about SSL. SSL was the predecessor to TLS. Pretty much the same concept. Oh, we have another question here. Okay, if I can get the polls to work. Try that one. Okay, waiting for just a couple more people. Oh, there's another one. All right, everybody's answered. Didn't fool too many people. No, the correct answer is C, should use a hash. Yes, when you get a key, don't use just the characters that the user entered. Run them through a hash. In fact, you can put them in a loop and run them through the hash of a hash of a hash of a hash several times. Then it becomes so random, mixed up that the bits are quite random. Because yes, Unicode, the upper bits are often 0, and that's not very random. So you want to use, of course, people should use long keys if they're using input keys, but then just run it through a hash, like a SHA-1 or SHA-256. Hash the key, then use the hash as the actual encryption key. Okay, that's enough background information. Let's get into some important stuff. Here are some security goals. This is what we've been talking about all semester. What do we want to accomplish? Confidentiality, that is, nobody can see our data. Integrity, nobody can change it. Availability, our systems continue to run. That means no denial of service. Authentication, that means we can validate who we are. Authorization means we can, once we've authenticated ourselves, we can determine who is allowed to do what. And anonymity, we want to keep our privacy. We have not talked about privacy much in this class, but it's an important aspect of computer security. Okay. And here, as I threatened, are the OWASP Top 10. These are the most important or most threatening vulnerabilities that the OWASP organization finds by viewing websites. And we'll go over, I have several more slides on these, but we can see this is injection, like SQL injection, broken authentication, that is authentication that doesn't work very well, sensitive data exposure. That's part of that, it's just not encrypting things. HTTPS helps there. XML entities, access control, security misconfiguration. That often means just not making it secure, not configuring the system so that it is secure. Of course, we know about cross-site scripting. We didn't talk about insecure deserialization. Several languages, for instance, Java, if you have an object and you want to send it across the network so that the other side can use it, you have to flatten it out. It's easy to send a number or to send a character string, but to send an object that has multiple values, you kind of have to flatten it out or serialize it, get to the other side and restore it. And that's not always done as securely as you would like. Then using components with known vulnerability talks about using open source software, and then insufficient logging and monitoring. We haven't talked much about that, but that's very important. You need to turn on some monitoring so you know what's happening. It's interesting to note that the average time to figure out that you've been hacked is over 200 days. That's a long time. That's, what is that, 7 or 8 months later? So you get hacked and you don't know it. Okay, so let's talk about some of those. We'll start with them in the order we're given. Okay, so SQL injection. It is important to use SQL correctly. And I know from the previous survey that a lot of you are taught only this method for creating a SQL. This is not good. This is full of problems. Never, ever do this. For instance, you get some sort of user data, and that could come from something in the user input, and put in there. We know that if you concatenate these in the proper way, you can fool SQL into thinking the command is different, particularly with this things like 1 equals 1, so it's always true, and you get data. So that should never be done. You can try to whitelist your input data, sanitize that. The very best way. This is simply not use concatenation. I still like this XKCD cartoon. And you might note in the third is the answer to one of the previous test questions. Yes, okay. Okay, how do you fix it? Best way, the easiest way in my opinion, is prepared statements. They're really easy to use in SQL. And they always work. Because if you use prepared statements, in the data, whatever the user types in, is data. It never interprets it. It never tries to consider it part of an SQL statement. And there's other things to do, but use prepared statements. But stored procedures are also effective. These are the most, you can do the others, but they're not nearly as effective. Here's an example of an SQL prepared statement in PHP, but it's very similar in other languages. You don't have to put the silly $signs in front of every variable name if you're doing like in Python or something. Okay, but basically create an SQL object. There's your query, but you put a question mark in there where the data is supposed to be. Then you do the prepare thing. Then you do the bind with a string. We want to put this string, the user data, into the command where the S was. Basically, put it there, but tell it that when you want the data, take it from this variable name, and then you can execute it. And then you get the results back and do whatever you want to. One of the nice things, this is actually much more efficient in the other way, because if you want to execute this multiple times, and sometimes you need to get them, you can just change the value in this variable and execute again. You don't have to do the prepare or the bind again. You just change the value in the variable and execute it again. Bingo, it keeps running. And that works very well. So remember that, do not use concatenated statements in SQL. Okay, input. Of course, if you want to filter your input, here is an example where we had a regular expression. And we all know about regular expressions, but this one's safe. A regular expression that can be used to check the data. So if the data doesn't match the regular expression, then if you go report validity, it will come up with a false if the input. If it's true, or if report validity is true, then that means it's okay. If it's false, that means it's not so good. So here, if it's false, we just write it there. Okay. It's pretty simple to use, and it works quite well. There's report validity and check validity. Report validity also displays an error message if it doesn't work well. Okay. So I have a question about input validation. Let's try that one. Oh, okay. Half of you responded. The other half may have fallen asleep already. Three more people. Come on, take a guess. There's another one. Another one. One more. One more. Come on. Somebody answer correctly, because everybody's answered incorrectly. Oh, I should flunk the lot of you. No. You've answered, the true answer is on the server. You have to check validity on this. Oh, it's nice to use JavaScript. You can use regular expression. A good answer would have been all of the above, but it's most important that you check on the server. Remember ZAP? Yes. You could check JavaScript, use a regular expression, have a wonderful looking input, send it over to the server, but somewhere along the way, somebody could use ZAP to change it to something that wasn't correct. You have to check it on the server. You can't trust that users are nice. You can't trust that they won't be doing something nefarious. So the proper answer is on the server. If you just use the other two, you're in big trouble. Questions about that? Everybody ashamed now of their answer? Well, I hope so. Okay. Moving along. Okay. No, come on the server. All right. Rainbow table. I didn't cover this before, but some people weren't. Well, I thought I covered it, but I want to go over it because people aren't really. A rainbow table is a list of pre-computed hashes. In other words, say you want to check somebody's file of, somebody has a file of user IDs and passwords, and the passwords have all been hashed. And now you're wondering, oh, can I figure out how to log in? Because the passwords are hashed, I can't tell what the real password is. I only have the hash. That's not really going to stop you too much, because a lot of people use stupid common passwords. People, the top most common passwords are very frequently used. So what you do is you take the list of common passwords, and you hash them, and you see if that hash matches any of the hashes that you got in the file. If it does, bingo, you now have a password that works. You could do this by calculating the hash for each one, or you can save time and pre-calculate the hashes of all of them, put them in a big file, and then just read in all the hashes. That way you don't have to calculate it when you're. And in fact, if you structure it properly, you can have a hashed map, a hashed file of hashes. And so you don't even have to like serially look at it. You can index into it. Now, what if they use assault? Assault is a random number that they append to the end of the password and then hash it. And you don't know what the random number is, but you have to keep the salt in the file with the user IDs and passwords, because you have to know what the salt is to calculate it again later. You know, when somebody enters a user ID and password, you want to check and see if it's correct. You got to go out to that user ID, pick up what you think is it, take the same salt, hash your entered password with that same salt and see if it matches. Now you can do that for all the popular ones, so it doesn't really slow you down too much. It just means you have to calculate them all, and you can't really pre-calculate them. Okay, a good way to avoid some of these problems is multi-factor authentication. That is, make sure that you do not just passwords, but that and something else. This is also the answer to one of the questions on the exam. But multi-factor authentication, most commonly, the way I've seen it implemented, everybody wants to use your phone. So you have to enter your user ID, enter a password, and then the system will text your phone with a code. And then you enter the code, and then you're logged in. That's multi-factor because it's not only something you are or something you know, like your password, but it's something you have. You have to have your phone. Now, if somebody steals your password and they steal your phone, well, then they got in. And obviously, don't keep a list of passwords on your phone. Okay, I can't help. This is from the cartoon, The Incredibles. Is it going to play for me? Oh, sorry, it's not going to play for me. It's How disappointing. Oh, there we go. All right. Password, hand scan. Yes, I like that. She uses password. She uses a hand scan, iris scan, voice scan. She checks very carefully. All right. Okay. XML, external entity attacks. We know all about these. The big thing is when you have an XML file, you can say, oh, go out someplace and get this file, which can be a URL. So you can go out and get it someplace else. Or you can get it from your file system. In other words, it's not necessarily have to be on the website file system, but it can be outside the web file. So you can just say, oh yeah, and copy this file in here. And therefore, if it's going to be sending back data back, you'll have a copy of that file. It's a sneaky way to go out and get a copy of the file. Cross-site request forgery. That was another one of the OWASP big ones. Basically, the idea is that if somebody is logged in to a website and you send them a carefully formatted email or the link, or get them to click a link, that link will then try to go out to that website. Since they're already logged on, your browser already has the cookie for that one, that if they access it, it will consider the user to be logged in because you have the cookie for being logged in. And so you can send requests to the victim's website and it will act as if you are logged in. And so the attacker can make requests of the website as if they were logged in because you are. To stop that, there is the same origin policy. That is JavaScript or whatever script you had to be using cannot get data from any server except from the server where this web page originated. So you can go back to the origin web page and get it, but you can't go to any other one. This holds for JavaScript, but it doesn't always hold for other means of accessing it. In other words, if you want to do JavaScript XML HTTP request or a fetch function, that'll get it, but you can't do those. What you can do, images. You can always go out and get an image from another site. A lot of times to put web pages together, instead of copying the image to my server, I just reference it directly from the server where the image is located. I always wonder if I'm violating copyright rules because I didn't copy it. It's still there. But you can do that. And who knows that the image actually has to be a valid request for an image. You can have a website waiting for you to make a request for an image. This is the HTML image request source, but instead you can be sending them data. In other words, this allows you to send data to the other website. And so your evil website can accept that request, store the data away, and then send back an image just so it looks like it's working. Forms also allow you to send data to any place. Here is a HTML form. This is using the post method. You can send data out to my evil website here. Anyhow, now, one thing I don't have here is you can specify that all these are hidden, that all the values do not appear on the screen, but instead they are hidden. And then you can use a JavaScript to initiate the form. So in other words, you can have a form that contains input that the user didn't input, that sends data to another site. You can just change the values of the variables and then send them off. And that will send data to another site. How do you fix that? Well, there are a lot of built-in systems. People are working on this because obviously it appears in the OWASP Top 10. Somebody's concerned about how to fix it. So they got all sorts of frameworks that you can use. Use tokens other than cookies. Don't rely on the cookie to be your only method of origin security. You can also check in the HTTP header, the origin and the referrer values to you, who sent you here. And they may not be, check and see if it's someplace that you want it to be sent from. Often, it should only be from your website. If it's not from your website, you go, oh, something's wrong. And then there's the same site cookie option, which is only send this cookie back to the same site where it came from. Don't send it anyplace else. Now, we all know about cross-site scripting. Cross-site scripting is a pretty simple concept. You put JavaScript, or whatever your scripting language is, into the input, and then at some point when the browser wants to display that value, it displays the text, but if the text has JavaScript, it will execute the JavaScript. And therefore do it. So if you have some nasty JavaScript in there, it'll do it. It's one of the big attacks. And it's been hit a lot of places before. So yeah, and we've talked about how to do that. One of the biggest is you should cleanse the data that you get from the user, make sure it has no characters that it shouldn't have. And I have another question similar to an exam question. So let's try this one. Hey, it's true and false. You're never going to see a true and false test question from me, so click as you can. All right, everybody's finished. And there are the results. As you can see, a couple more people clicked false than true. False is the correct answer. Okay, HTTPS does share certificates, and thereby, if you go out to a site and when it gets the certificate back from that site, you can make sure that the certificate is from the site that you want it to be from, and that's correct. But a phishing attack may redirect you to a different site. Now, if you want to go to www.acme.com, then if you go there, it will validate that that's acme.com. But if you have a phishing attack that sends you off to another site where you thought it was Acme, if the other site has HTTPS, well, in fact, turns out somebody did a study and said, yeah, these are what percentage of the evil websites have HTTPS. Well, it's not hard to buy a certificate. Well, it costs you about $100 to get a certificate. So that's an awful lot of money. So yeah, you're securely connected to the evil website. Yeah, but of course, if your browser bar says you're connected to acme.com, then you're probably connected to acme.com. But a lot of people will go to www.acme.evil.com. And Acme's in there, you don't notice the rest of it, and suddenly it doesn't work. Okay. I think I mentioned this last time. When I review all these problems, so many of them seem to be related to interpreting text as instructions. When you do PHP or JavaScript, you're mixing up the text, the HTML commands, and the PHP code all together. With JavaScript, you've got the data you're going to put into the web page mixed in with JavaScript and other commands, executable commands. And the big problem is that somehow you've convinced the browser to execute the data. And that causes a lot of problems. Yes, SQL injections, other command injections, cross-site scripting, cross-site request forgery, and several others are all related to the same problem. Now that you are experts in the area of web security, think about how to fix that. Somebody's going to go out there and say, let's stop doing this. For my example, Microsoft Word. When you look at Microsoft Word, you see the text. You don't see any formatting in there. The formatting is there in the file, but it's not in what you see. There ought to be some way to fix this. I haven't figured it out yet, but hey, we could figure it out and become millionaires. So if you got an idea, let me know. We'll work on it together. I'll share $1 million with you, or you can share $1 million with me. Okay. So what have we learned? Well, first of all, that a lot of users are not well behaved, that they don't always do what you want them to do. Somebody's out there running Zap and changing things after you change them. Don't put anything where the user can get it. In other words, we didn't even talk about one of my favorite ones is where you have a website that you're going to buy something and it displays all the items and their code numbers and their price. And then it sends the price in the request back to the server to buy it. Well, if you change the price, it turns out that's the price you pay. So you typically change the price, it used to be $100, change it down to $1. It's much cheaper that way. Save yourself $99. But don't do that. Don't put the data where the user can get to it. Remember, they've also got Zap and they've got the debugger for the browser. They have a lot of access to what's going on. Don't put anything there. Keep it all on the server. You can use encrypted session keys and send data that way and send it back. And of course, insiders. I read an article that said, we just don't seem to be paying enough attention to the insiders who know all about how your system works. They know how to hide what they've been doing. And sometimes they can be attacking your system for months, years, maybe forever before they're discovered. Maybe they're never discovered. Okay, that's my review. I have a public service announcement. This is for undergraduates. If you are an undergraduate and you are graduating this semester, and I'm not stopping you, so but I am a senior project advisor for like 3.5 senior project teams. So some people might get stopped there. But anyway, the university wants to know what you're going to do next. Are you going to go to graduate school? Do you have a job? Are you going to sit around doing nothing? Or are you going to, go out to Peace Corps, whatever you're going to do? Somebody's going to say, so go out to the ncat.joinhandshake.com and fill it out. The university wants that. The department wants you to fill it out. The college wants you to fill it out. Everybody's really interested in this stuff because it does consider, people want to know, where do our students go when they graduate? Oh, and I tell you the truth, yes, that was my usual answer when they ask us. The administration always asks, where do your students go when you graduate? I don't know. Go wherever they want to, I assume. But now they have a survey. So go out there. If you are a graduating senior, please do this. They really want you to do that. And it's pretty simple. So I like this quote. That's why you're here. Hopefully you've learned enough to prevent that. Okay. All right. Any questions about that? Actually, a question. What? Excuse me?
None at the moment, I was saying.
Okay. A question I do have for everybody. Maybe we'll take care of it right now. Let me stop sharing the screen. Yes. Were there topics that you thought were important that we failed to cover in this class? What's missing? I don't know if I'm going to teach it again, but I'll pass this on to the next guy. Anything we missed? Apparently not. Okay. I tried to get the OWASP Top 10 there. I thought those were important. All right. In that case, go back to, let's find out how that, there's a blank screen, but we will fill it with information about the exam. How do people do in the exam? All right. Blasted. Microsoft. Curse you, Microsoft. Okay. There are the results of the exam. Look at that. Boy, what a softie. I used to be department chair. And when I saw results like that, I was really suspicious. I brought the faculty member in my office and say, what the hell are you doing giving everybody an A? And look what I did. I gave almost everybody an A. Okay, as you can see, there were lots of A's, a couple B's, and a B minus. So that's it. Nobody got a C plus. Nobody flunked this exam. What fun is it for a faculty member? I can't flunk the lot of you. But you did very well. Yes. So hopefully you seem to know it. I didn't think the exam was too easy. I don't know. Maybe you thought it was too easy. Yeah. Did anybody think the exam was too easy? I mean, obviously it was, but did you think so?
Not really, I guess.
I'm sorry. I couldn't hear that.
It was not too easy. Okay. Some questions give take time. I had to think a lot. I won't say it was a too easy exam.
Okay. Well, as you know, my exams were 18-hour exams, and seems from the surveys, people took 3-4 hours to do it on the average. Some poor souls took 8 hours to do the question. I'm sorry, I had no intention to make it an 8-hour exam. But yes, I wanted you to learn the material. And I confessed to our department chair that I'd given a bunch of A's. And she said, well, it's okay as long as everybody knows the material. And I think, in general, most of you know it. So that's the third exam. When you take that with the previous exams, using the grading scale, and I don't know, the grading scale is kind of easy. I mean, some people complain that, you can get an A down to 87. I mean, it's not like the Greensboro public school system where you have to get 93 and above as an A, Yeah, I've always thought that was pretty bad. You have to know everything. Nobody in the real world knows everything. I mean, in the real world, if you get half of it right, you're doing pretty well. Okay, here are the results from the whole semester grade. Once again, what a softie. I gave out a whole bunch of A's, There are 2 A minuses, a B plus, and 2 Bs. That's it. And so what are we going to do about that? Well, I contemplated giving a killer final exam so I could just wipe you all out and fix all those A's. Or, so the end of the semester, don't you love it when the instructor at the end of the semester gives you 4 or 5 assignments to do? No, I'm not going to do that to you. So I decided, okay, after clearing it with our department chair, I decided, okay, everybody knows what the grade is. If you like the grade, fine. You can keep it for the semester. That's your semester grade. So a whole lot of you got A's. Bingo. None of those people want to take the final exam. Several of them told me that. How about those A minuses, B plus, and Bs? They have the option of taking a final exam to improve the grade, or they can accept the grade they have. And just for the record, just for full disclosure, if you take the final exam and hope to improve your grade, but you screw it up, your grade could go down. No guarantee. Everybody except for one person has responded to that. I'm waiting for one person. If you haven't responded, please do. Very shortly, I'm going to assume your answer is you don't want to take the final one. I just won't do it. Okay. All right. Well, enough of that. And now, unless anybody has any questions about the exam, tried to answer the questions. I tried to answer questions on Blackboard, giving you an explanation as to why you didn't get that. There were some common, yes, every time I grade, doing this for 29 years now, people make common mistakes, and I have a file of the common mistakes and how many points you take off. And I got to the point I would just copy and paste into Blackboard and say, oh, you did that. That's 2 points off. Okay. And in case you checked, I tried to make it a little bit more difficult to cheat this time. Not as good as previous, but the exams were all different. Often different meant they were in a different order. Well, that will fool them. But also some of the questions were slightly different. For instance, the celebrity one. You had your choice between Bill Gates, Donald Trump, and our current president, Mr. Biden. All of them had all the information you might want on Wikipedia. Okay, so let's then go out and look at another topic now. I talk about this in many classes because I find many people don't do this well. So if I can get back to Blackboard, let's go back and share the screen. And yes, protecting your data. This is extremely important. Yes. Yes. Computer hard drives and the computers will all fail. It's not a matter of if they'll break, it's when they'll break. They're mortal. They will all break eventually. And so how well you recover is a matter of your preparation. So I want to talk about backing up your data and checking what we can do, giving operations. So a little background. So how do we lose our data? User error. That is, user error is where you accidentally delete something. You press that little delete button and you go, oops, I shouldn't have done that. Now, usually it happens to me milliseconds after I've pressed that button to delete something. I really like the recycle bins, but sometimes things get out of the recycle bins and you go, oh, I should never have deleted that. I lost a couple programs. I'd written several apps for my phone. And then I thought, oh, I wasn't doing anything. And Android Studio is a huge application on my computer. And I was thinking, I'm not doing that right now. I'll just unload Android Studio to free up some space. Well, when I unloaded Android Studio, it took out my apps. I lost those. Well, okay. Then I switched phones and I go, oh, I'll reload the app. Oh, it's gone. So user error. I am in the process of rewriting the apps better than they used to be. Okay, so user error is a big one. Also, lost media. Yeah, put it on a USB drive and then you lose the USB drive. Another one, of course, is disk failure. Yes, your disk will break. Data corruption. That's where the somehow your disk is still hardware working, but it can't find the files. The file system gets screwed up. And of course, that's part of operating system failure. The OS does something, and now it won't read your file. Power failures, yes. In order for performance, the operating system caches a lot of information in the RAM before it writes it out to disk. Yeah, if you study OS, particularly Linux, Unix systems, they cache a lot of stuff out to the RAM because the RAM is so much faster than the disk. And so it does it right out to the disk until it feels it needs to. But if the power goes out, it doesn't have the time to write it out to the disk and you lose it. And then, of course, there's the natural disasters. Your computer can get destroyed by whatever. If you have a house fire, your computer gets burned up, and your backups get burned up, you're out of luck. Malware, that could include ransomware. That screws your data. And of course, people can steal your equipment. I'm thinking here, a laptop. You got a laptop, you leave it in your car, somebody breaks in your car and steals it. That happens. Interestingly, that seemed to happen a lot, used to happen a lot to government employees. And not only would they lose their laptop, but they would have national secrets on it, and they'd lose that. Here's some information that I got out from several sources, so I haven't cited. It's a combination of several sites, but what causes these? Hardware failures is a big one. Hardware failures accounted for 41%. Human error accounted for about a third of all the failures. So frequently, that's where you do it to yourself. And then software corruption, that includes some sort of corruption to the file, to the disk space or the data. Malware, including ransomware, is about 7%. Theft of the device, and then natural disasters are only about 3%. Although natural disasters are usually a big loss. So, since you note, it's less likely that somebody else will destroy your data, that you'll do it all by yourself. Okay. And what does your data cost? For a lot of companies, it's everything. You have a company, particularly like a software company. If you lose the source code to your software product, your goose is cooked. That's it. In fact, I'll show you the next slide. But yeah, so the data is everything. And by the way, not only does it mean loss as far as, it's nobody has it, but it can be stolen and somebody else has it. So it can be everything for a company. You just close up shop. You have to consider, what does it cost to lose your data? And even as Joe average six-pack using his computer, he's got stuff on his computer that he doesn't want to lose. I've got all sorts of information. I've got, information about accounts I have, and information about, I have all of my class information for the semester and for the past 29 years on my computer. I'd rather not lose it all. And you have to think about, what is that going to cost if you lose it compared to the cost of backing it up? Also consider the fact, if you're working on your senior project and you're struggling along, what happens if something gets lost? Oops, you just lost your senior project. Now, if you haven't been backing it up to GitHub or anything, you're screwed. It's over. You're not going to graduate this semester. Come back next semester. And then say, well, what is it going to cost? What's the probability that a failure will occur over a period of time? Well, the probability of a small period of time may be low. Over a lengthy period of time, it's extremely high. And again, this is interesting. Again, that's a 70%, comes from several different views, but say small business, they just go out of business. I mean, if they lose their data, that's it. If you're a small software development company, you're an entrepreneur, you're out there, you've got this app that you're putting out, and it's starting to sell, and you're starting to make your big money, and then you lose it. Well, you're screwed. What do you do now? Yes, 70%. That's a lot. It means if you lose your data, you just killed the company. So what can you do about that? So to make sure, as you are working on something, save the results. The little thing, you've got that save button. As you are typing along, busily working on something, typing in, typing a paper, press the save button every now and again. If you're writing a program, save it. If you're writing, the next great American novel, press the save button every now and again. Because remember, if you press the button, only once in the evening when you're done, then you can lose the whole day's information. If you press it every half hour, you only lose a half hour's worth of information. So click it. It's just a click. Take the effort to click it. I love that one. Now, some systems are really big. Before we go too far, I've got some polling information. So let's do this. Oh, I'm sorry. Has that been stuck on your? Here's a multi-question poll. Please fill this one out. Can you see the poll? Hello, anybody there?
Yes, we can.
Oh,
yes,
okay.
Sir.
Okay,
We
thank
can
you.
get all of them.
Sometimes it's really hard to tell what people can and can't see. Okay, far away. Okay, please answer the questions. There's no right answer. This is just an opinion. It's anonymous, so you don't have to worry. I'm not watching what you're answering. Okay, I'm still waiting for a couple more people to answer. There goes another one. Okay, the other people may have fallen asleep. Anybody else want to? All right, well, I'll call it end of this and we'll look at what people answer. Share results. Okay, you should be able to see the results now. Yes, where do you store your results? Hard drive. Hard drive turns out to be the best answer. Because you remember, one of the problems is losing your data. USB thumb drives is not a good answer. They get physically lost. External hard drives is a pretty good answer. Somebody once said that they're a better answer. They had an external hard drive kind of hidden in their desk with just a cable that came out to the computer. And when somebody stole their computer, they didn't get their external hard drive. So they just lost the hardware, not the data. External hard drives work pretty well, although hopefully you have USB 3.1 these days. USB 3.1 is quite fast. But if you don't have, if you're still like USB 2 or even worse, it's much slower. Your hard drive is much, much faster. But for Pete's sakes, don't whoever's out there using a thumb drive, stop it, save yourself. Okay. So when do we back up our computers? A couple of people have never in there. You are in deep trouble because, as I said, it will break. Your computer will break, and then you'll lose everything. Longer than a month, about a month ago, around a week ago, we have one soul who did it sooner than a week. Okay. I've been computing for 50 years now. See the gray beard? I've backed my stuff up multiple times every day because I've learned. You will learn. Oh, how about your phone? Now, yes. Oh, people are better with their phones. Now, some people have services that back up your phone. I know you can buy a service that will back up your phone to the cloud every now and again. And then, of course, have you ever lost your data? So the people who've never lost their data go, who cares? I'm not going to lose my data. I'm afraid I'm in the many times guy. Well, after 50 years, if it only happens once every 10 years, it still counts many to me. Yes, be careful. The hard drive will break. The OS will screw up your data eventually. And of course, things get stolen or destroyed. That plague of locusts will come by and eat you up. So watch out. Now, back to the slide. Some people are really concerned about backups. Yeah, sometimes you have a system where it's very important. For instance, I happen to know that the lottery system, the North Carolina Education Lottery, where almost none of the money goes to education anymore, but the North Carolina Education Lottery, the server, when you buy a ticket and it runs through a little machine at the grocery store, it goes to a server that records that number was purchased at that location and saves it. It also has another server that's about 50 miles away, and every time it updates the database on that server, it sends the update to a server 50 miles away. So it's very hard to physically take out both servers at once. I remember in a place where I used to work that every time the database was updated, they did an audit trail. In other words, the system wrote out what did the record look like before we did the change? What did the record look like after we did the change? And so if they had a failure, they just reloaded the data back to the latest backup, and then used the audit trail to restore it back to where it was when it died. This, by the way, was back in the ancient days, and they used magnetic tapes. Magnetic tapes, which are miserable things, but they are separate from the computer, and it was usually very hard to take out the computer and the tape at the same time. So if there was a disk failure and they lost the database, they'd restore it from the last backup they had, and then run the audit trails to get right back where they were and not lose any data. There are hardware things. RAID. RAID is redundant array of independent disks, or redundant array of inexpensive disks. It's a bunch of disks that appear to the user as one big disk. They can be implemented by hardware, or they can be implemented by software. Your Windows or Unix systems, Linux systems will support both of these, where you can have multiple, usually they have to be identical disks, and then it will combine them together to make it look like one great big one. Or you can have a hardware RAID unit, and the controller does it all. And so to the operating system thinks you have one great big disk out there. The advantage is, by storing extra data on the disk, they can recover in the event that one of the disks breaks, because we all know that disks will break. And so you write it out with multiple disks. And so if one of them breaks, you still have the data. You can recover all the data. And so there are different RAID types. By the way, there is a 2, 3, and a 4, but nobody uses those. RAID 0 makes it faster, doesn't provide any recovery. Mirroring, the RAID 1 is a mirror. As you have a cop, you have just 2 disks and a second cop. That works pretty well if you have a minor amount of data. You can put 2 disks in your drive. So if one of the disks breaks, your data is on the other drive, and it just keeps on running. Often, if you have a hardware record, it doesn't even stop the machine. It just alerts come up. Oh, we had this failure. And then at an appropriate time, you can stop it, put a new disk in. Some of them allow what they call hot swap. You can pull the broken disk out, put a new disk in while it's running. And while the system continues to run, it will copy the data that's missing back onto the new disk. And so in a couple of hours, you're back to where you used to be. RAID 5 is very popular if you have lots of data. If it takes more than one disk, so if data, then use RAID 5, and it will survive the loss of one drive. And if you're really paranoid, use RAID 6, which will survive the loss of 2 drives. So Again, thing you have to remember about RAID, RAID works really well if your disk fails. On the other hand, if you delete the file, the RAID system will carefully remove it from all your files. So it's gone. It doesn't save you from that. You know, if you get ransomware and it encrypts all your files, it's gone. Also, what happened to me once, I had a RAID system and the disk controller broke. And I had RAID 5, it stripes the data across all the disks. Well, all the disks had a fraction of each file, and so it was pretty much useless. Okay, now, what are the common ways to back things up? Frequently, what people do is they'll back up on some quarterly basis or whatever, end of the semester, end of the quarter, or once a month, back up everything, back up all the data to some media. And then every day, you do an incremental backup. An incremental backup just backs up any new files or any modified files. So it just goes through, looks at all your files, and how much do you change every day? Not too much. So it's not a lot that's backed up every day, except once a semester or so, you back up everything. Now, where do you back it up? There's all sorts of choices. And that depends on how reliable is your backup. How much does it cost? Well, cost is always a factor. How fast is it? How much can it hold? And the ability to restore an individual file. That's sort of a media and a backup system. Some people have a backup of the whole system. You can restore the entire system or nothing. It's important to be able to restore an individual file because often when you make that mistake and you delete your file, it's one individual file you broke. And then how long will it last? This is particularly important in archiving of information. How long will your media last? And a really important part about that is how long will you have a device that will be able to read it? I mean, there's a lot of, what if you have a floppy disk? Nobody has floppy disk readers on their computer anymore. So even if you had a floppy disk that's carefully preserved, nothing will read it. It's useless. Here are some medias that I can think of. CDs, they're nice. They're kind of, 600, 750 megabytes. It's not all that big anymore. I have files bigger than that now. DVDs are bigger. And they have, DVDs you can write once, that is, you can write it once and then it's read-only. After you write it, it's read-only. Okay, that's kind of nice. That has a nice feature that you can't be changing. There's read-write DVDs that you can write and write over them and write over again and update them. And 4.7 gigabytes is quite a bit of data. But if you need lots of data, Blu-ray writes up to 50 gigabytes in that sucker. But if you really want memory sticks, the USB thumb drives, the thumb drives are getting bigger and bigger. I went out and took a look, just went out to Amazon to buy a thumb drive. They have 2 terabyte thumb drives now, about physically the same size as the little ones we have. Yes, you can see thumb drive. Yes. Yes, I keep having to buy bigger ones. I'm on the archive committee for the church, and we have a thumb drive with a string that goes around it that is the amulet of the archivist that we pass back and forth to other people. And we keep having to buy bigger ones. Okay, but those are all physical devices. You can go remote server. Again, if you have a commercial system, you might have a server in some other location. It can be expensive, but it's very secure. External hard drive, as I mentioned, that's something you can do. You can back it up to an external hard drive. Actually, that worked well before we got USB thumb drives that are really big. And then cloud. Cloud has become very common these days. I back myself up to the cloud and the external hard drive and a thumb drive and occasionally CD. But anyway, yeah, cloud works really well. You can buy a cloud service and automatically starts up at whatever time you want, backs things up, anything, does a incremental backup. And then if you accidentally delete something and you want to go back and get it, you can run the program and pick a file from a given day and restore it. I strongly recommend that you not use tapes. There are still companies out there that try to sell you tapes for backup. I can tell you, tapes are the worst media in the world. First of all, of course, they're sequential. So if you need something in the middle of the tape, you got to stream down the tape to find it. And they break and they corrupt data. Don't use the tape. Now, when you back something up, don't keep your backup media right next to your computer. Because if you have a natural disaster that takes out your computer, it's going to take out your backups too. Of course, don't make it too difficult to go back and get your media. Long ago and far away, we had a mainframe computers. The company did a incremental backup every night at 3 a.m. or 3 a.m. So at 3 a.m., they backed up all the incremental backup of all the files. And then on Friday nights, they did a full backup, which took quite a bit of time because you had a lot of disk space. But every full, and then they'd rotate sets of tapes. And so they did the full backup set of tapes to go out downtown to the local bank, and they put them in the vault, and then they take the case of tapes they had there and bring them back. So we had a week-old set of tapes in the vault in the bank, which we thought to be pretty secure. And so if something took out the computer room, we wouldn't lose everything. But in fact, we had an agreement with another company in town who had a similar computer to ours that should a natural disaster occur, they would allow us to use their computer for critical things like payroll. You know, if you don't pay your people, they get kind of upset. And so, yes, if our computer got destroyed, we had a plan. We would take the old tapes, and even though payroll might change every week, we could at least run the old payroll stuff and print the same checks they got, 2 weeks ago. And that would do okay for most people. Somebody get paid more than they were supposed to. Somebody wouldn't get paid, but we'd figure that out on a manual basis. At least, 95% of the people will get paid. You don't pay your people, they start to get upset. So back things up, keep those things up. And here's a sad story. This is true. A poor graduate student, this is a couple of years ago, was working on their thesis, and they were concerned about backups. They, had everything on their hard drive, and then they backed it up to floppy disks, and they kept that floppy disks in a box of floppies, and they, rotated through. And so they had several backups. They could, go back and look at several revisions of their thesis. And then some thief came by and stole the computers and took the box of floppies. So they not only lost their computer, they lost their thesis. It was gone. They were not happy. Okay, now remember, since this is a security class, watch out for your backups, because while your computer may be terribly secure, you've got passwords and your backups may be just plain text sitting there on the shelf. If somebody gets your backup, they can get all your data. The simple solution to that, of course, is encrypt your backups. Your backups should always be encrypted so that people can't see them. Okay. Cloud backups, as I mentioned, a lot of companies out there who will sell you backups. And because we're running out of time, we will not do this, but there are things you can do to keep your computer safe. Here are my 10 recommendations. Of course, this is keeping your data safe. This is the whole realm of computer secure, information assurance. Well, back up your data. If you get ransomware, you can just thumb your nose at those attackers, clear out your system, reload your data from your backups, and you're all set. Of course, antivirus software. Now, the antivirus software has its limits. You should make sure it does automatic updates. Antivirus will find the known attacks are protected. But if somebody has a new one, like that, use network address translation and a firewall on your network. That makes it very difficult for somebody to see your network address translation. Means that you have one set of addresses on your local network, and as you go outside to the internet, there's a different set of addresses, and your router usually translate. That way, somebody can't go into your network because they don't know the addresses. And besides, the network address relations box won't allow it. And same thing with firewall. Another feature, auto run. Auto run means you stick a CD into your computer and it starts playing it. Well, for music, that's generally not too bad, but you don't want it to automatically start executing it because a lot of CDs will have this auto run thing. Oh yeah, you stick You want to install the software, you put the CD in, it starts up automatically. That's nice for installing software. But who knows what somebody's put on that CD so that when you stick it in your computer, it automatically loads something on your computer. Don't do that. Manually start it. Of course, strong passwords, we talked about that. Long and random. Again, as Bruce Schneier said, if you have a long random password, they're hard to remember. If they're easy to remember, then they're not long and random. Frequently, there are several techniques. I find thinking of a phrase, a sentence or two, and then using parts of the phrase as the password. Of course, keep your systems up to date. As attacks are found out, most systems are vulnerable to previously known attacks. So if you have the updates in, then you're probably secure against the previously known attack. On the other hand, if you didn't, you're going to get killed by an attack that you could have prevented. Oh, and then go out to your system. You'll find there's a lot of things that start. This is startup when you log on your system. People complain, gee, my computer's slow. I need to get a new computer. Actually, probably not. The hardware is not slow. It's the software that makes it slow. One of the things I always look at is go out to, well, let's see if we can do this. I think you can see that now. That's Microsoft's Windows Task Manager. Boy, somebody's out there using up my computer. Oh, Zoom. Well, yes, that would make sense. A lot of the network's getting pretty well used because we're zooming things in and out. GPU's falling asleep, but okay. And memory's pretty moderate. Anyway, yes. If you go out here to startup, these are the programs that start up whenever you log on your computer. And you might notice I have a whole bunch of them disabled because I don't need those things to start up. A lot of people think there's, if you buy their software, then there's nothing, you should run their software every time you turn on the computer, that this is a must. No, I don't think you want to do that. So don't, so stop those, delete or disable programs that start up all the time. They don't need to be there. And they're running in the background. Heaven only knows what they're doing. And of course, talking about phones, and I kind of flowed over my top 10. Same thing with phones. Watch out. There's a lot of phone apps out there that you end up on your phone. Where the places that come from? Get rid of them. And as you install things now, used to be with like Android, it said this app needs all these features. It's either let it do everything or don't let it do anything. You can't install it. Now you can be picky. You install an app to do something and it says, oh, it wants access to your contacts. And you're going, why does it need access to my contacts? It's not anyway related to that. Don't give it access to your contacts. Don't just go clicking, okay. Read it. Yes. If you can't imagine why this app needs that access to that thing, don't let it. And then, of course, browser plugins, once again, if you don't use it, don't keep it. The things wander into your browser. And watch for phishing. Again, you'll recognize the phishing attacks. Return address or the link is not what it should be. They're very generic. It doesn't, if your bank is going to contact you, they know. They don't just say your bank account. They'll go and say your platinum card on Bank of America, and they know with the last 4 digits of your account, they'll know who you are. If they don't know who you are, it's not the right bank. Also, strangely enough, a lot of phishing attacks programmer. Oh, yes, I was going to show some of your, in the exam, one was send me a phishing attack. Some of you were great. Some of you had very convincing phishing attacks. They looked really good. And did a very good job. Some of them were not so much, but most of them were just wonderful. They looked convincing. And some of you thought up imaginative reasons why I should click. Another couple of, I'm kind of blown out of my top 11. Surge protector or an uninterruptible power supply. I have uninterruptible power supplies. Those are really wonderful when the power blinks. An uninterruptible power supply is basically a battery system. You plug the UPS, uninterruptible power supply, into the wall outlet, and then you plug your computer and your monitor and stuff into the UPS. If the power drops, then it takes power from your batteries. Now, usually it won't last very long, depending on how big your computer is, how big your battery system is. You know, it might last for 20 minutes. It might last for 4 or 5 minutes. But it's usually enough for you to go, oh, when the lights go out and the only thing lit in your room is your computer monitor, you go, oh, time to, shut down, close everything, save your files, turn off your computer. And that way you'll do a shutdown that won't lose your data, as opposed to all of a sudden blink. The computer only has to go off for a second for everything to get lost. And of course, don't leave your laptop in an unattended space or in your car where people can see it. I had a friend who worked for the police department who told me here in Greensboro, the most common crime in Greensboro is theft from cars. It's not stealing the car, it's stealing things out of the car. People will forget to lock their doors. In fact, some of the malls are the most common areas for crime. People walk down the row of cars pulling on the car doors. They can do this without hardly anybody noticing until they find a car that is not locked, and then they take interesting things from it. Or if there's something really nice in there, sometimes it's the smash and grab. Okay. Anybody think I missed anything? Any? Okay. Yes, we have an
You mean like in this whole thing?
Yeah. Well, yes. Either in the course, in my list of things, is something missing that we should have mentioned?
The only thing I can think of I thought was pretty cool or interesting is about the tape drives. Believe it or not, they're actually used in some cloud infrastructure to actually hold older data that hasn't been accessed in a while. And new kinds of tape drives are used. Yeah, basically, that was the only thing.
Yes. Well, yes, they can be cheap on a per byte basis. And that was one of the requirements. On the other hand, it's been my experience that the reliability is low. First of all, tape drives break all the time. Back in the old days, tape drives the most common device on the computer to break would be the tape drive. And so, yeah, if you have a tape drive that breaks, you might have to buy a new one so you can get back your old data. Yeah, so you have to be careful. There may be a use for them, but I'd find something else. If you're using a tape drive now, consider changing your media. It's just been my experience that tapes don't work well. They are prone to loss. But, whatever. Anything else? Basically, remember, you can lose your data all by yourself. This is Pogo from Walt Kelly way back in 1971. But we've met the enemy, and he is us. You can. All right. Okay. We'll cancel this idea. There is no final exam. Everybody, except for one person, and I see you logged on. I'm not going to say right now, but I need to know whether you do or do not want to take a final, because you're the only person. Okay. I have texted them. I'd like them to reply. Other than that, this is it. We're done for the semester. Hope you enjoyed the class. People did much better than I expected. I think we tried to cover important stuff in computer security. Many times it appeared like I was teaching you to be a great hacker. Probably are. That was not the purpose of the class. Trying to teach you how to protect yourself against hackers. But once you know how the hacking works, how people have done that, then you should know how to protect yourself against it. So, okay, have good luck on all your finals. You don't have to worry about the final exam in this class. You already know what your grade is going to be. And so that's it for the semester. Thank you. And perhaps I'll see you another time.
Thank you, Dr. Williams.
Okay.
Bye-bye.
Oh, and don't forget to fill out the teaching evaluations. Yes. So if I've made any mistakes, just, slap me up beside the head and tell me what I did wrong. So go out there and fill them out for all your classes because they are important. The administration really cares about them. And I care about them because this is how I know, I wasn't doing that very well. I can try to do better next time. You don't know. It's all rule. You can't manage what you can't measure. And so if I don't know what I'm doing wrong, unlikely I'm going to fix it. So, okay. So thank you very much.
Question for you.
Yes, ma'am.
Okay. So are you going to take any other classes in next semester?
No. Remember, I'm an old retired guy. See the gray beard? I'm not teaching any class in the fall. I may come back in the spring, maybe. But I don't intend to teach a class in the fall. I'm trying to phase out. I spent a lot of time in this class. I hope you learned just at least half as much as I learned because I didn't know this material. I was not a web security specialist. Dr. Yu has been the only person who had ever taught this class before since it was invented. And then she handed it off to me and said, I can teach, well, for several reasons that I would. I get to teach it. So
it was very useful when coming to the fact of knowing how to defend yourself, especially by telling us the vulnerabilities, I think, at least from my experience. So telling us the vulnerabilities with the HTTP or with the form inputs and all that, the echoes and how to badly code your website, definitely helpful.
Yes, it's easy to make a mistake. We did all sorts of things that we thought were okay, that even some of our instructors told us were good things to do, but they're not. And it's not that hard to do it right. In many cases, you can do it well with very little more effort than doing it poorly. And then you're safe. Okay. The student who says they want to take an exam, email me, please. We need to arrange something. So that's it for the semester. Again, thank you for taking the class. I actually enjoyed teaching it. I learned a lot. Hope you learned a lot. And so see you next time, whenever that may be. Okay.
Thank you, Dr. Williams.
Okay.
It was a
Bye,
wonderful
folks.
semester.
Thank you.
Bye.
You have a good break.
Thank you. You too. Hey, Mr. DeWitt.
How you doing?
Hi. So you want to take the exam? I think you have a, excuse me?
I have a B.
You have a B.
Right,
Okay.
and I'm trying to hire it.
Let me just, excuse me for a moment. Let me just open up my spreadsheet of all the exams and see how we're doing. Come on, Microsoft, open up grades. And Nicholas DeWitt, you have a B. You have a 77.7 average. You got to get up to 82 to get to the next. Yes, in fact, yes, 77 is the point where you drop to a B minus. So you are 0.7 above the B minus. So you need to do better. The question is, how much better do you need to do? Well, that's where we have algebra. Hang on for a second. Let's see if we can do this. Okay, you see the whiteboard? Mr. DeWitt?
Yes, I see it.
All right. So you want to get the next better grade. And to do that, you have to get a grade of 82, I think. yes, you have to get your score. So you want to get an 82. And that equals we're done, since the final accounts for 20%, you've already done 80% of the score right now. So, and you have a score of 77.7. And then the final exam, which counts for 0.2 times final. We'll go F as in final. Okay, there's an equation, algebra. So in order to get an 82, you've already got 80% of your grade is determined by 70%, and you need that. So let's do a little algebra here. We go 82 minus 0.8 times 77.7, all divided by 0.2 equals what you have to get. It's an equal sign on the final, right? Like the algebra?
Okay.
So I get out my calculator. Get out my calculator and I go 82. Let's go 0.8 times 77.7 goes that. Change the sign, add it to 82. And divide that by 0.2. And I get a 99.2. So if you're going to take the final and you're going to get a B plus, you have to get a 99 on the final exam. If, on the other hand, you get anything less than a 77 in your grade will drop down to a B minus or worse. I'm not trying to threaten you. I'm not at all. Please, I just don't. I'm just doing the arithmetic. This is how it works. So now, do you want to take the final or leave it at a B?
I think I'll leave it at a B.
Yeah, because that comes to 99.2, which really means you have to get 100 on the final to get a B plus. Well, sorry, fella. Was there things in this class that I noticed? Well, let's see. Looking at your grades,
I didn't really have a good background with JavaScript.
What's your major?
Coding. I'm an electrical engineer major.
Oh, okay. Well, we won't hold that against you. But in my experience, I know electrical engineers don't particularly like to program. If they like to program, they'd be computer engineers.
Right.
Yes. I mean, I've taught electrical engineers many times before. Yes. Okay. Well, you're not in as bad a shape as the people who were criminal justice. I had a criminal justice students. Boy, I mean, I understand why they take the course, but they didn't know programming for nothing. And there was a little bit of programming in there. And to be honest, I didn't really realize there were non-computer science people in the class until, several weeks into the course. I think probably into the first exam. And I go, why are these people doing so bad? Oh, they don't know anything about this. Sorry.
Right.
Yeah. Well, yes, I apologize. On the other hand, it is a computer science course, computer science graduate class.
Yeah.
Yeah. Okay.
I'm actually a junior.
Oh, you're undergraduate. Let me see. Oh, yes, you're an undergrad. How about that?
Yeah.
Yeah. Yes. Well, it is a graduate class. You're taking a graduate class in a different discipline from your undergraduate major. And yeah, you might expect it to be a little difficult. I mean,
right.
Yeah. I'm sorry it was so difficult. I guess I didn't realize in the beginning I had people from other majors, because I've been teaching classes for decades. This is my 29th year. It's a long time. You're probably not 29 years old.
Nah, I'm not.
No, I've been programming for 50 years. That's, your parents may not be that old, but, anyway,
Right.
yes. So I didn't realize that because usually I don't have too many. I should have, this semester, I did not do a beginning of the semester survey and ask, what's your major? And I often do that. And then I find out, oh, I've got people who want computer science, which generally didn't happen. Okay. Well, anyway, in summary, if you don't want to take the final, you can keep your B.
Okay, I think I'll just take the B.
Okay. I mean, that's your option. I don't want to force you into anything, but we do the arithmetic and
Yeah.
You're right on the edge of getting a lower grade. You don't want to do that. I would be, I hate to say it, I'm getting soft in old age. You're the lowest grade in the class.
Yeah.
Sorry. And I would, I'd like to, usually I flunk students. Oh, I'm mean. Not because I want to flunk students. This is, in some sense, this is really nice. I think almost everybody learned something. I had these long exams and you couldn't just guess and figure out my exam.
I could say this is probably the class I learned the most in.
Well, that's good. So I'll keep your B. You don't have to take the final. In that case, good luck on your other finals. You won't have to study for this one. Study hard for the others. And I think you'll do well because it looks like you're an interesting student who's interested. I'm sorry that the course is hard for you. Yeah. All right.
All right.
See,
Have a nice day.
Bye.
Bye.